Hey everybody, welcome back to the lab. Today, we're going to actually be able to observe interference in waves. Sound waves are a very common type of wave that we're all familiar with. Just like any other kind of wave, they experience interference under the right conditions. I have here two speakers connected to this frequency generator. I have the frequency generator set to 680 Hertz. This means that when we turn it on, both of these speakers will produce a constant 680 Hertz tone. We're then going to modify the setup a little bit and see how that affects the sound that we hear. Let's start with the first scenario from your DL. Turning this on, we can hear the constant 680 Hertz tone. It's coming from both of the speakers and they're interfering constructively. Now let's see what happens if we switch around the wires to one of the speakers. Hopefully, you can hear that the speakers have gotten much quieter. Interestingly, it's not either of the individual speakers that are actually quieter. They're still producing the same tone at the same volume. But from where you're sitting, they sound much quieter. Why might this be? Well, that's what you're going to talk about in your groups. Let's try a different scenario. Because I've picked a frequency of 680 Hertz, the wavelength of a sound wave coming from one of these speakers is approximately half a meter. Let's see what happens to the sound if we move one of these speakers by half a wavelength, corresponding to about a quarter of a meter. As you can hopefully hear, the sound has gotten much quieter. As before, it's not because either of the speakers changed their volume. It's just because the sound waves are now destructively interfering. What happens when we combine these two effects into one, both switching the wires going into the speaker and moving one of the speakers forward by a half a wavelength? Hopefully, you can hear that the sound has gotten much louder again. This is because the two effects are now canceling each other out. Individually, they would result in destructive interference, but together they result in constructive interference. Now let's see what happens if we do the same thing as in scenario 2, except instead of moving one speaker closer by a half a wavelength, we move it closer by a full wavelength. Hopefully, you heard the sound get quieter and then louder again. When the speakers were half a wavelength apart, the sound waves were destructively interfering. For a full wavelength, this becomes constructive interference again. Check out the next video to see how we can use phase charts to analyze why these effects happen.